All right, here's another video from chapter 3. We're talking about the normal distribution. In this video, we're going to get into the empirical rule. And so we'll talk about that briefly. But from the last video, the idea was supposed to get you kind of comfortable with this picture, essentially. So what I want you to be able to do is two things. First off, if you're given information like what you see in green over here, I want you to be able to draw this picture. So there's really three key facts over here in this information given in green. The first is that the thing that we're talking about, height of redwood trees in that example, is normally distributed. You'll see that it's always going to be normally distributed because in chapter 3 we're studying the normal distribution. So all that tells you that it's normally distributed is that when you draw your picture, you're going to draw something that is symmetric bell shaped. So it kind of looks like this. The other two pieces of information that will be given to you are the mean and the standard deviation. So in this example, there are 250 and 30 respectively. And so from that information, you know to put the mean in the middle and count up and down by the standard deviations and space things out in such a way that by the time you're 3 standard deviations above the mean or 3 below the mean, you're pretty far out into the tails here of your distribution. So the first thing is to be able to draw your picture. The second thing is to be able to interpret what it means when you shade in regions of that picture. So the idea there is that there's two different interpretations of the shaded region, and we'll get into that more in this video. In the last video, I just said pretend this was shaded in, and somebody told you that area was 34%, and you were supposed to know that that means either of these two things here. In this video, we'll kind of flip it around a little bit, and I'll ask you a question that'll tell you what to shade, and then you'll learn how to figure out how much area is in that shaded region that you shade in. And you'll figure out what to shade in based on the question that's asked. Maybe without further ado, I should show you how to do that. So here we go with the empirical rule. Turns out that learning objective that I just described, where you're trying to figure out how big an area is that you shade in, to figure out that area, there's two different ways to do it. You can use functions on your calculator, or you can use this thing called the empirical rule. So we'll be answering the same questions in each of the next two sections. You're supposed to learn two different ways to do it. So the empirical rule. What the empirical rule tells you is, in a normal distribution, it sort of makes sense that we're talking about a normal distribution because all of these questions are about the normal distribution. The empirical rule tells you that if you're lucky enough to have a normal distribution, approximately, and that's a key word here, what you'll see with the empirical rule is it just approximates these areas. This area, it turns out it's not exactly 34%, but it's pretty close to that. It's approximately 34%. The empirical rule just gives you approximations. In a normal distribution, approximately, and then there's 3 different statements here. The first statement says 68% of the area under the curve. Maybe I'll go downhill a little bit here so I can write one long line. Lies within 1 standard deviation of the mean. What am I talking about here? I'm saying that if you had an example, maybe we should do an example concurrently. So right about here, I think will give me enough room. Suppose my nightly sleep. Sure, why not? Is approximately normal, meaning the amount of hours I sleep in a given night is approximately normal. How's that for being lazy? With a mean of, let's say, 8. That's probably not true. It'd be nice if it were, though. And a standard deviation of, I don't know, let's say 1.5. Sure. Suppose you're given this information right here. You're told that the shape of the number of hours that I sleep on a given night is approximately normal. So that tells you when you go drawing your picture over here, you're going to draw something that is symmetric bell shaped, at least as best you can. That's actually a pretty nice one. And then you're told the mean here. This can be given to you in English like it is up here, or it can be given to you symbolically. Note that it's the population mean. So this isn't something that you calculate. It's something you're told to assume the population mean is 8. And the population standard deviation is 1.5. So when I make my scale here, so that by the time I'm 3 standard deviations above the mean or 3 standard deviations below the mean, I'm pretty far out in the tails. These tick marks should each be 1.5 apart. So if I start at 8, 8 plus 1.5 gets me up to 9.5. 9.5 plus 1.5 gets me up to 11. And 11 plus 1.5 gets me up to 12.5. If I do the same thing in this order, 8 minus 1.5 gets me 6.5. And then subtract 1.5 again, you're down to 5. And then 3.5 here. You can use a calculator for all those. This isn't meant to be, can you do arithmetic in your head kind of questions. So maybe you're given this. What if I asked you the question, on what or in what percent of nights I sleep, and then I'll put a colon here. And for the first question, I'll say between 6.5 and 9.5 hours. If I asked you this question, you've already drawn this picture just based on this information that was given. And then you're like, 6.5 hours, that's right here. 9.5 hours, that's right here. What he's asking me is how much area is there underneath the curve between 6.5 and 9.5. And you're like, whoa, slow down. How'd you know that the percentage of nights that you sleep between 6.5 and 9.5 hours corresponds to the area underneath the curve between 6.5 and 9.5? That's this interpretation, right? The percentage of all, whatever I'm talking about, redwood trees, nights of sleep, whatever, being between these two numbers is one of the interpretations of the area underneath the curve. If I said, on what percent of nights do I sleep between 6.5 and 9.5 hours? I guess that's a question, so maybe it deserves a question mark. What I'm asking you, in other words, is how much area is there underneath this curve between 6.5 and 9.5? You're like, I don't know how much area is underneath the curve between 6.5 and 9.5. Yeah, you do, because you have this empirical rule. And the empirical rule tells you that 68% of the area under the curve lies within one standard deviation of the mean. And luckily, conveniently, the question was asked in such a way that 6.5 is exactly one standard deviation below the mean, and 9.5 is exactly one standard deviation above the mean. So since 68% of the area lies within one standard deviation of the mean, I just shaded in exactly 68%. The answer to this question would be this picture and then the number 68%. And you're like, do I really need to draw the picture? Yes. Why? Because I want you to be an expert with these pictures. Because right now, you probably don't. You probably could have answered this specific question without drawing the picture. But the downside to doing these without drawing the picture is when it gets harder later on, if you don't have the knowledge, if you don't have this to fall back on, in harder examples, you might really struggle. So for this question, even if you don't want to, I'd kind of like you to answer it this way. You're like, I thought I remembered you saying in the last video that the empirical rule was hard. That doesn't seem that hard. The answer is 68%. I mean, what else could it be? Of course it's 68%. Okay, let's review this one. Remember up here, I wanted to figure out, I don't know, what percent of all redwood trees are between 250 and 280 feet tall. You go shading that in, that's a different picture than what we have down here. Right here, it's one standard deviation below to one standard deviation above. Here, it's the mean to one standard deviation above. So how can we figure this out? Well, what we can do here is we can use the empirical rule and we can take advantage of some of the symmetry of this distribution. Right? If you look at this area over, I don't know, maybe in green or something. Sure. This area in green does not represent trees that are between 250 and 280 feet tall. It represents trees that are 220 to 250 feet tall. So if the question was what percentage of trees are between 250 and 280 feet, you would not want the green part, you'd only want the red part. But maybe you'd be able to recognize that red and green together is exactly 68%. So if red and green together are 68%, the symmetry of this distribution tells me that both red and green individually must be half of 68%. In order for this plus this to be 68%, since they're symmetric, they must each individually be 34%. So that's where that number came from the previous video. What else can I do? Well, let's see. I guess I could ask you, on what percentage of nights do I sleep? How about more than 9.5 hours? Try that again. There we go. You're like, surely that's not an empirical rule question. More than 9.5? That's got nothing to do with this within one standard deviation of the mean. I'm like, well, where is it then? Fine, I'll draw you the picture. I'm a little bit annoyed drawing your pictures every single time, but maybe I start to do them quicker. There's 8, there's 6.5, There's 9.5. Maybe if I'm being really lazy, I just label the 9.5 and then put my tick marks down and call that good. What's he asking me for? More than 9.5? I guess that would be to the right of this 9.5 here. I got to figure out that area. It's not 68%, right? Because 68% would be from 6.5 to 9.5. Here's my 68% in here. So what is it? What's green? Well, the idea this time is to recognize that the total area underneath the curve always has to be 100%, right? On all nights, I get some amount of sleep. I mean, maybe it's 0 hours. All trees have some sort of height associated with them. The total area underneath the curve is always 100%. So if I know that 68% is shaded right here, I know that 32% is not shaded. So you're like, so the answer is 32? No, because there's non-shaded area over here and over here. The white plus the green would be 32. But if the white plus the green is 32, and because of symmetry, the white and the green are each the same, then this has to be half of 32. There's 16%. On what percentage of nights do I sleep more than 9.5 hours? That'd be 16%. If I asked you the question on what percentage of nights do I sleep less than 6.5 hours? Be awesome if you could answer that immediately. Right? Maybe you don't even need to draw a picture, but if you're still learning this, draw a picture. Less than 6.5 hours. Wait, isn't that the exact same as the last question? Yeah, kind of. It's still 16%. Why? Because less than 6.5 would be that region. And this region has to be the same as this region because of symmetry. Looking at them, they're the same. There's the same amount of area over here as there is over here. So if this was 16% on this side, then this has to be 16% on this side. That's the kind of stuff you can do with the empirical rule. You're like, okay, so the answer is always going to be either 68% or half of that, or 16% or 32%. Like, it doesn't seem like there's that many possible answers. The questions can only be about 6.5 hours and 9.5 hours. And it doesn't seem that bad. Turns out, no. Turns out there's 3 different statements to the empirical rule. The empirical rule tells you that 68% of the area under the curve lies within 1 standard deviation of the mean. It also tells you that 95% of the area underneath the curve lies within 2 standard deviations of the mean. And while we're here, it tells you that 99.7% of the area under the curve lies within 3 standard deviations of the mean. The empirical rule is sometimes called the 68, 95, 99.7 rule, because essentially you need to memorize these 3 numbers and understand they correspond with 1, 2, and 3 standard deviations above and below the mean. So how does that work? Maybe I need to ask some more questions here. How are we doing on time? 13 minutes. I'll go a little bit longer here. What if I asked you on what percentage of nights do I sleep, I don't know, between 5 and 11 hours? I suppose that were the question. All right, fine. I'll draw the picture again. I'm a little bit annoyed drawing your picture over and over again, which is why I'm making them uglier and uglier every single time. But fine. There's 9.5, so I guess that would be 11. And then there's 12.5 out there. And there's 6.5, so I guess that would be 5. And there's 3.5 out there. And what I'm trying to figure out is the area from here to here. First, the answer is not 68%, right? Because 68% went from 6.5 to 9.5. This goes from 5 to 11. How can I figure out what the answer is? Well, you have to recognize that this 5 is 2 standard deviations below the mean, and this 11 is 2 standard deviations above the mean. And if you recognize that this 5 is 2 standard deviations below the mean, and this 11 is 2 standard deviations above the mean, then maybe it makes sense to use this second statement in the empirical rule, and you figure out that this area is 95%, so that this answer is 95%. If you're following that, that's great. If you're looking for a little shortcut, how did you recognize so quickly that this was 2 standard deviations below the mean? I mean, I guess you can just count the tick marks if you want. Another option, which probably isn't necessary at this point in the class, but it'll be something if you think about it this way now, it'll make your life easier later, is there's really a lot of similarities between this picture and this picture. Yeah, this one was talking about sleep and this one was talking about the height of trees. You're like, they're totally different, right? But they both have some mean in the middle. Maybe I'll label that with a 0. And then they both have 3 numbers above that and 3 numbers below that. Maybe I'll label those 1, 2, and 3, and -1, -2, and -3. And even without using any statistical vocabulary, maybe you sort of see why this is drawing the pictures this way kind of makes sense. It doesn't really matter what the problem is about, right? Sure, it's about sleep or about redwoods or whatever. I'll label the values of my hours of sleep here. But when I'm using the empirical rule doesn't say anything about 6.5 hours or 12.5 hours or anything like that. So what I really need to do is I need to convert these into something that shows up in the empirical rule. And how do you do that? It's actually something we've learned. These are all z-scores. If you think of your observations as x's, these numbers below them are z-scores. Because remember, z-scores back from 1.6 just tells you how many standard deviations above or below, if they're negative, the mean a given observation is. If I told you the mean was 8 and the standard deviation was 1.5, and I asked you for the z-score of 12.5, back in 1.6, you would have said, oh, right, the z-score is the observation minus the mean over the standard deviation. So if you want the z-score for 12.5, I take 12.5 and I'd subtract 8, and then I divide that by the standard deviation. I'd get 4.5 over 1.5, which is exactly 3, which is the z-score that corresponds with this x value. So if you want, when you draw your pictures, make sure you include the hours of sleep or the height of the redwoods or whatever that we're talking about in the problem. But if you want, beneath that, you can write the corresponding z-scores. And that might seem like overkill for these problems, but I think you'll find if you do them that way, it's a little bit easier. It's less likely you'll make a mistake. It corresponds better with what you have written down here for the empirical rule. And it'll end up being more useful later on this class when we get into a really difficult topic called hypothesis testing. These are what are called normalized values. And essentially, they just let us compare any normal distributions. Right? This normal distribution and this normal distribution are really the same. If I ask you what percentage of nights do I sleep between 6.5 and 9.5 hours, I'm really kind of asking you what percentage of trees are between 220 and 280 feet tall. And if you could see that connection, you're really starting to understand the empirical rule. A couple more empirical rule examples. What if I said between 5 and 12.5 hours? This one's hard. This one's super hard. Your first thought might be, oh, you screwed up, right? You've made too many of these videos today. It's time to stop making videos. You're obviously getting tired. You're drawing ugly looking normal distributions for one thing. But you're also asking the wrong question. Because look, let me show you. The 8 goes in the middle, and then the 9.5 is 1 standard deviation above, and the 11 is 2 above, and the 12.5 is 3 above. And then if I count down, I get 6.5 and 5 and 3.5. And look, you said 5 to 12.5. The 5 corresponds with a z-score of -2. But the 12.5 corresponds with a z-score of 3. Didn't you mean -2 to 2? Or maybe -3 to 3? You couldn't possibly have meant -2 to 3 because the empirical rule doesn't tell me about -2 to 3. It tells me -2 to 2 or -3 to 3, but it doesn't tell me -2 to 3. How do I answer that question? There's a trick to it. And the trick to it is to break this up into 2 different regions. Split it in the middle. By splitting it in the middle here, it allows you to take advantage of symmetry. What we can do is we can figure out how much area is shaded in red. And then we could figure out how much area is shaded in green. Got this festive red and green picture here. And you might be like, ooh, watch this. I'm going to show off. Green, that's 50%. Because you said 100% of the area is under the curve somewhere. And because of symmetry, there's got to be the same amount on the right side as the left side. So that must be 50%. That's really good thinking, but it's wrong. And the reason it's wrong is because there's a tiny little bit of area to the right of 12.5. It's so little, it's hard to see. There's hardly any area over there. But there is area. How do I know there's area? Because the empirical rule tells me that about 99.7% of observations lie within 3 standard deviations of the mean. So what that means is 0.3% does not lie within 3 standard deviations of the mean. So 0.3% lies over here or to the left of 3.5 here. So we cannot say that the area in green is 50%, unfortunately, because there's a tiny little bit on the outside of it. But we can figure out the area in green. And we can figure out the area in red. And when we figure out those two areas, we can add them together, and that'll give us the total shaded region. And the total shaded region is the answer to this question. So how do we figure out those areas? It's kind of like this question. Remember how we figured out that this was 34% over here? We said 68% lies between a z-score of -1 and +1. So half of 68%, maybe I'll even write that, 68 divided by 2, 34% is between 0 and 1. You can use similar logic down here. 95% of observations are between 5 and +11. From here to here, I get 95% of observations. That's exactly the second statement of the empirical rule. 95% of the data lies within 2 standard deviations of the mean. If the question asked, on what percentage of nights do I sleep between 5 and 11 hours, the answer would have been 95%. It doesn't answer that. It doesn't ask that, unfortunately. But if from here to here is 95%, then half of 95%, you might want to plug that into a calculator or something, 47.5%, is over on the left. And similarly, if the question had asked, how much area is there from 3.5 all the way over here to 12.5? If it asked you that, you'd say 99.7%, because that's the third statement in your empirical rule. 99.7% of the area under the curve lies within 3 standard deviations of the mean. So from -3 to +3 z-scores is 99.7. But the green shaded region doesn't go from here to here. It goes from the middle to here. So half of 99.7, which ends up giving you 49.85%. You do enough of these, you start to memorize these things, is the area shaded in green. Ooh, so which one's your answer? Is it 47.5 or 49.85? It's neither of those, actually. Because the question is saying between 5 and 12.5, which is the total shaded region. I don't care if it's red or green. I just want to know what's shaded. I'm going to add up those two numbers. If you take 49.85 and you add to that 47.5, you get, let's see, can I do this in my head? Sure, 97.35, I believe. And that'd be the answer to this hard question. What you'll see, I'm going to give you a quiz on empirical rule. When you take your quiz on empirical rule, expect a bunch of questions just like this. Expect me to start you out with a situation where I tell you something's approximately normal, and I give you the mean and the standard deviation. And make sure you don't care whether I give it to you in symbols or in English like you see over here. And expect me to ask, 3 or 4 questions that look a little bit like these. And note those questions can be formatted as the first interpretation or the second interpretation. All of these were formatted as the first interpretation. I said, in what percentage of nights do I sleep between 6.5 and 9.5 hours? If I wanted to format them in terms of the second interpretation here, I'd say, what is the probability that on a randomly selected night, I sleep between 6.5 and 9.5 hours? You'd be like, either way, all you're asking me is how much area is there under the curve between 6.5 and 9.5. And the empirical rule doesn't tell you anything about 6.5 and 9.5, but if you convert those 6.5 and 9.5s to z-scores, then maybe you can see how to use the empirical rule. And what you'll see with the empirical rule is sometimes it's easy. Sometimes the answer is one of these 3 numbers. And sometimes it's kind of medium difficulty where you have to cut one of those in half. And sometimes it's really, really hard where you have to be clever how you come up with the answer. And there's lots of different ways you can come up with this same answer, by the way. 97.35. Some students don't find it by the red and the green region adding them up. Some do more of a subtraction method. There's lots of different ways you can get the right answer. However you're getting the right answer, if you're getting the right answer, you're good. Typically where students are at this point and they're like, all right, I think I might be able to answer exactly these questions, but I'm not feeling comfortable that I can answer any of them. I need a lot more practice. Well, what I'm going to do is I'm going to make another video where I just ask you a ton of these, maybe 10 questions. And I'll go through them quickly in each one, and I'll show solutions to each one. And if you can view that as more of a worksheet, right? Typically you view these as, all right, I'm going to watch you do it, I'm going to learn. I think watch this video to kind of learn, and then test yourself on the next one. where there's like 10 of these questions. They're all written up. Maybe I'll even type it up, get all fancy with you guys. And I'll ask you a bunch of questions, try them on your own, and then compare them to my video solutions. And if that makes sense to you, you're an expert on the empirical rule. One last comment on the empirical rule. There's another way you can do it. There's a shortcut method. The shortcut method is not quite as useful later on in this class, but it'll work. If you're the student who's like, look, I'm just trying to get my C. I don't really care too much about this stuff. I'm not understanding what you're talking about right now. I just want the path of least resistance. Give me an easier way to do this. There's an easier way. I will show you an easier way in another video that I'm going to call optional. And if this first way can make sense to you, I recommend doing it this way. Skip the optional video. But if you're just not going to get this and you want a way that is objectively easier than this way, it's a little bit more memorization, but it's easier. You never have to think about cutting things in half and adding or subtracting different regions. It's just memorization. If you want a memorization method, watch the optional video. But if you don't, skip straight to the empirical rule worksheet, try them on your own, and then watch my solutions. That's all I got on empirical rule.